Hi guys, this is a video solution for class 12th CAMONTEST that happened yesterday. So this will be physics solution. Let's get started with the first problem. The first problem says the radii of curvature of both the surfaces of a lens are equal to r and it's made up of a material of refractive index 1.5. Its focal length will be. Alright, so we know what to use. We have to use lens maker's formula that says 1 by f equals to mu lens upon mu medium minus 1 over 1 upon r1 minus 1 upon r2. So if I keep this here, I'll get 1 by f equals to mu of lens, that is 3 by 2 minus of 1. Mu of medium, if nothing is given, you have to assume it's air, and this would be 1 by r minus of minus 1 by r, and that would give you 1 over 2 of 2 by r, that is nothing but 1 by r. So f comes out as plus of minus of r, depending upon whether it was a concave lens or a convex lens, whether this was minus 1 by r minus of 1 by r. Question number 2 says an object is placed at a distance m times the focal length of a divergent lens. The size of the image is shorter than the object by. Alright, so we have to find magnification. So what's happening is we have a divergent lens. Let's make the principal axis. Object is placed at m times the focal length. So let's say focal length was f and it's m into f. Now let's try to apply lens formula. It says 1 by v equals 1 by f plus 1 over u, and that would give me minus of 1 over mf minus of 1 over f, and that is equal to mf common, and here will be minus 1 and here will be minus m. So v comes out to be mf over minus of 1 plus m. Now you have to find the size of image is shorter than the size of object, that is height of image over height of object, that's also equal to image distance over object distance, and that will be here minus mf over m plus 1 over object distance, and object distance, as you can see, is minus mf. So minus of mf, this gets cancelled, and this is shorter by how many times? M plus 1 times. Third question says a lens behaves as a converging lens in air and diverging lens in water. The refractive index of the material is. Alright, so again lens maker formula that says 1 by f equals mu of lens over mu of medium minus 1 over 1 over r1 minus 1 over r2. This is also called as thin lens formula. So f is coming out to be positive when it is in air, and f is coming out to be negative when it is in water. Alright, so that means this thing is changing signs. When it is in air it's positive, and when it is in water it's negative. So it says a pretty simple thing, mu of lens over 1 minus 1 is positive, that is greater than 0. So mu of lens is at least greater than 1. Now if you use this, it says mu of lens over mu of water minus 1 must be less than 0 because it's negative. So that gives me mu of lens over mu of water must be less than 1, and that gives us mu of lens must be less than mu of water, that is 1.33. So option number C. Question number 4 says a double convex air bubble in water will behave as. Okay, so we have a situation like this. So we have water and we have a bubble like this. Now again we have to use lens maker formula to determine what's happening. So 1 by f equals mu of the material over mu of the medium minus 1 over r1 minus 1 over r2. That gives us mu of air over mu of water minus 1, and this will be 1 by r minus of minus 1 by r, that is positive 2 by r, and this is negative. Hence, focal length comes out to be negative. It will act as a divergent lens. Question number 5 says, a lens of focal length f projects m times magnified image of object on the screen. The distance of screen from the lenses. Alright, so it's given there's a lens like this. Focal length is f. Now there's a screen somewhere which produces m magnification. That is, height of image will be m times height of object. Now object is here somewhere. Let's say this distance is u. Now you know that hi by ho is also equal to v over u. So this v is also equal to m times u. So v equals m into u. Now let's apply lens formula. 1 over v equals 1 over f plus 1 over u. Now we have to put everything with sign here. So v is positive, so it will be plus of m over u. F is also positive, so it will be 1 by over f. But this is negative, so it will be 1 over minus u. Now if you solve this, you'll get 1 by f equals 1 over mu plus 1 over u. Take the LCM, mu is the LCM, and this is 1 plus m. So you get mu equals f times 1 plus m. That is a D option. Question number 6 says, a convex lens of focal length f is placed somewhere in between object and the screen. Let's make the diagram. So there's a convex lens, there's a screen, there's an object. Alright, the distance between the object and the screen is x, so total distance is given. This is x. If the numerical value of magnification produced by the lens is m, so m equals to hi over ho, and it's also equal to v over u. Then the focal length of the lenses, so you have to find out f. What is f? So this is exactly like previous question with little bit of changes. So let's say this is t, this would become x minus t, and from here we can say that v equals m into u. So x minus t must be equal to m times t. So this is our first equation. We get the second equation from using the lens formula, that is 1 by f equals 1 by v minus 1 by u. So 1 by f equals 1 by v, which is equal to 1 over x minus t minus of minus 1 over t, which is nothing but plus of 1 over t. And if you add them, you'll get x minus t into t, x minus t plus t, and this will be x over x minus t into t. Now you just need to replace t with m. So if you can take this equation here, this x minus t equals mt. So x equals m minus or plus 1 into t. So t equals x over m plus 1. Now just replace it over here. So here it will be x over x minus x over m plus 1 and into x over m plus 1. So as you can see, m plus 1 square will go to the top, and this will give me mx plus x minus x into x. This x gets cancelled, and you get m plus 1 whole square over mx, but this is equal to 1 over f. So option number 1. Question number 7 says, a rod of certain metal 1 meter long and 0.6 centimeter in diameter, its resistance is this much. Another disc is made up of same material, 2 centimeter in diameter and 1 meter thick. We have to find the resistance. So you know that resistance equals to rho into L over A. So from here you can say that R2 over R1 equals rho 2 over L2 over A2 over rho 1 into L1 over A1. Now rho 2 and rho 1 are same because they are made up of same material, so this goes out, and R2 over R1 has a simple thing as L2 over A2 into A1 over L1. Now just put the values. L2 is how much long? 1 millimeter, so 10 to the power minus 3. Area 1 is 0.6 in diameter, so 0.3 squared into pi gets cancelled anyway. Area 2 is 2 centimeter in diameter, so 1 square into pi, and length 1 is 1 meter long, so pi gets cancelled, and we get R2 over R1 equals 0.09 into 10 to the power minus 3, and R2 becomes 9 into 10 to the power minus 5 into 3 into 10 to the power minus 3. That's nothing but 2.7 into 10 to the power minus 7 ohms. Question number 8 says a uniform wire of resistance 100 ohms, so this wire has resistance 100 ohms, is melted and recasted into a wire of length double that original. What would be the resistance of the wire? Alright, so we know it's pretty simple question. Initial volume equals final volume, and volume equals area into length, so A2 into L2. Now if L2 is twice L1, then it simply says that A2 must be A1 over 2. Hence R2 over R1 becomes rho L2 over A2 over rho into L1 over A1. Rho cancels, and we get the same thing, L2 over A2 into A1 over L1. Now L2 by L1 is also 2 times, and A1 by A2 is also 2 times, so 2 into 2, 4 times, so that means answer would be 400 ohms. Question number 9 gives you a diagram and asks you what is the equivalent resistance between this X and this Y. So let's say they are connected with a battery of voltage V. Now this problem would be difficult if there was a connection between them, if these two wires were connected like this, but this wire passes over the other wire, so this problem becomes pretty simple. So you can say this and this and this are parallel connections, so here I1 will go, here I2 will go, here I3 will go, and I1, I2, I3 is equal to I. Now if you see again, I3 is getting diverged into I4 and I5, and then all of them are meeting together at Y. This says a simple thing. It says that first these three were in parallel, and then out of this 2 more parallel connection arrows. So this question becomes quite simple. Resistance of this part is 12 ohms, resistance of this part is 4 plus 2, 6 ohms, because they are in simply series. So first 12 and 4 are in parallel, and then finally this parallel combination is also in parallel with 6 ohms and another 4 ohms, this guy. So everything is in parallel, so you can directly say that 1 over R equals 1 over 12 plus 1 over 6 plus 1 over 4 plus, did we miss anything? Yes, plus 1 more over 1 over 4. So this gives me LCM would be 24, 2, 4, 6, 6. This is how much? 6 plus 6, 12, 18 over 24, and R comes out to be 24 over 18, which is 6 into 3 and 6 into 4. So 4 over 3. Now question number 9 also says the exactly same thing, that you have to find the resistance between X and Y. So let's again join them to a battery. This is going like this. Let's say battery has potential V, so we can assume this potential to be 0 and this potential to be V. Let's assume this potential to be X and this potential to be Y. Alright, from symmetry you can say that if from here, let's say I1 current was going from here, I2 current is going from here, and I3 current is going from here, and as it is symmetrical, that I1 current will come from here and I2 current will go from here, and I3 is anyway going from this side only. So this says a simple thing, that there is no current in this particular resistor, so you can remove them. And if you can remove this resistor, then question becomes quite simple, that this 2R is in parallel with this 2R, which is again in parallel with this R. So we have 3 parallel resistances, 2R, 2R and R. So let's apply the formula. 1 over R equivalent equals 1 over 2R plus 1 over 2R plus 1 over R. LCM is 2R. This is 1 plus 1 plus 2. That is nothing but 2 over R. So R equivalent comes out to be nothing but R over 2. Sorry, this was question number 10. Now let's move on to question number 11. Question number 11 says equal charges Q are placed at the vertices of equilateral triangle ABC but only on two sides. The magnitude of electric field at C will be. Alright, so let's make A, B, C equilateral triangle A, B and C. So here is Q, and you have to find electric field at this point. So you know there will be two electric field, E1 and E2. This is 60, so this would also be 60, and if you do this, then this would be 30 and this would be 30. And you know that the Y component EY, E and E, so their EYs will get cancelled because they are same magnitude, E and E, and in here you'll have E cos theta plus E cos theta, that is 2E cos theta. So what is the net electric field at C? It is 2 into E, that is nothing but 1 by 4 pi epsilon naught into R square into Q into cos of 30 degree, root 3 over 2, 2 gets cancelled and you get root 3 Q over 1 by 4 pi epsilon naught R square. Let's move on to question number 12. It says electric field due to a charge at a distance 3 meter from it. So here is a charge and electric field at a distance 3 meters from it is 500 newtons per coulomb. The magnitude of charges, alright, so what should be the electric field at this point? It should be 1 over 4 pi epsilon naught into Q over R square. So just putting the values over here, 500 equals, this total thing is 9 into 10 to the power 9 Q over 9, that is 3 square. This gets cancelled and you get Q equals 5 into 10 to the power minus 7 coulombs. That's also 0.5 microcoulombs. Question number 13. It says an electric dipole is kept in a non-uniform electric field it experiences. So you know that if an electric dipole is kept in uniform electric field, then it feels constant torque that is equals to P cross E. Alright, but if it is non-uniform electric field, then it will not only feel a torque, this will be this much, but it will also feel a net force on it. So correct option is A. Question number 14 says a charge of 5 coulomb experiences a force of 5000 Newton when kept in an uniform electric field. What is the potential difference between 2 points separated by distance of 1 centimeter? So we know that V, potential difference or integration of dV, is basically integration of E into ds, that is the displacement it does. Now if it is uniform electric field, then we can directly say it's E into delta S, and that will be equal to nothing but delta V. So we have to find delta V only. So delta V is equal to E, that is equal to F over Q into delta S. So F is 5000, Q is 5 coulombs, and displacement is 1 centimeter, that is 1 over 100. So this gives me answer 10 volts. Question number 15 says an alpha particle is accelerated through potential difference of 10 to the power 6 volts, and this is alpha particle. Alpha particle is nothing but helium nucleus. So what will be its kinetic energy? So from work energy principle, you can say that work done will be equal to its change in kinetic energy, and as initial kinetic energy was 0, you can say it is directly equal to the final kinetic energy. And what was work done? Work done on the charge is nothing but Q into V. So that is basically KE final. So that is nothing but 10 to the power 6 into 2E. It comes out to be 2 mega electron volt. Question number 16 says a charge of 5 coulomb is given a displacement of 0.5 meters. The work done in the process is 10 joules. The potential difference between the 2 points would be. Alright, so this looks like a pretty simple question. V is nothing but W over Q, right? So 10 over 5, that is 2 volt. The displacement doesn't matter. V equals to integration of E dot ds. So all the E dot ds, E dot ds, E dot ds, E dot ds it does, that will be equal to its potential difference. How much distance it travels, it's not a problem. Question number 17 says a loop of wire is rotated about an axis normal to a uniform magnetic field. The direction of the induced current reverses once after, and we know this, after 1/2 of a rotation. This is a pretty simple question of electric generator, right? So whenever change in magnetic flux changes its direction, that will be happening after half the rotation. So after that, induced current will change its direction. Question number 18. A non-conducting rectangular block falls from up in a uniform magnetic field. Then the magnetic field, the acceleration will be equal to G less than G. Okay. So you have a non-conducting thing, let's say a wood. Now if this wood falls into some, let's say, area with magnetic field, this magnetic field is not even applying any force on it, only gravitational force acts on it, so it will fall with just the acceleration due to gravity G. Question number 19 says the north pole of a magnet is brought near a metallic ring as shown in the figure. The direction of induced ring will be, okay, so it's just brought near, so we are not making it pass through, otherwise the answer would be different. So this is north pole, this is south pole, and this is how we are making it. So we are increasing the flux into this loop, so loop will try to compensate that by producing a current in this direction. So answer is anti-clockwise. Pretty simple question of Lenz's law, isn't it? Question number 20 says that two concentric loops, let's say this and this, lie in the same plane. The current in the outer loop is clockwise, so this is clockwise I. The current in the outer loop is and increasing with time, that means this is equal to some constant into t, so it's increasing, like it could be linearly, non-linearly, but it's increasing. So it's increasing basically magnetic field in downward direction, so flux through this loop in downward direction is increasing, and to reduce that it will produce a current in anti-clockwise direction, just like the last question. Question number 21 says a metal rod moves at a constant velocity in a direction perpendicular to its length. A constant uniform magnetic field exists in a space in a direction perpendicular to the rod as well as its velocity. So situation is something like this. Now it's moving through a magnetic field, let's say it's into this, and it's moving perpendicular to its length. So we know the EMF produced will be VBL. The entire rod is at same electric potential. That's not correct. There is an electric field induced in the rod. That is correct. Electric potential is highest at the center, decreases at its end. No. Electric potential is lowest at, no. So correct option comes out to be B, that there will be some induced electric field because of this changing flux. So that's what we say, that induced EMF is because of induced electric field ds. Moving on to question number 22. It says a metallic square loop of ABCD is moving in its own plane with velocity v in a uniform magnetic field perpendicular to its plane shown. The electric field induced is in AD, yes it is induced, but not in BC, no it's also induced in BC. In BC but not in AD, no, neither in AD nor in BC, in both AC and BD. In AB and CD there will be no induced electric field because V is in the same direction as L, but in AD and BC there will be induced electric field and induced EMFs at these two points. Okay, question number 23 says write the induced EMF between the free ends of a semicircular arc of radius r pivoted at A. The arc is rotating with angular speed omega and a perpendicular magnetic field B. So this is the situation. This point is A, this point is B, and there's an arc between them, and this arc is rotating about A with omega. Magnetic field is perpendicular, it's B vector. Now this is a classic case of motional EMF, which says EMF induced in the conductor is V cross B dot L vector, and here as you can see this is the L vector. So it doesn't matter what kind of loop it is, it's circular or it's like this L vector is what we are going to use. And if you see that if a rod rotates with omega, it has length L, then EMF generated in it across its end will be half into B omega L square. So we can apply the same thing here, and we can say that in this case also EMF generated is half into B omega L will be 2R in this case squared. So that will give us 2B omega R squared. That is option number B. Now question number 24 gives us a diagram and says a uniform magnetic field B fills a cylindrical volume of radius R. A metal rod of length L is placed as shown in the figure. If B is changing, okay, uniform magnetic field B, alright. So initially I think it was uniform, but now B is changing by the rate dB over dt. We have to find out the EMF produced by the changing magnetic field that acts between the rod. So we can say the flux change in this rod is equal to d phi equals dB into area. Area will be half into length of the rod is L, and let's say this distance is x, so half into L into x. Now EMF generated is nothing but d phi over dt, the magnitude of it. So this will come out to be dB by dt into L over 2, and x is nothing but, by Pythagoras theorem you can say that it's nothing but under root of r square minus L square over 2 square and under root of it. Hence option number A. You could also solve this problem if you remember one important result that says that electric field induced will be equal to R by 2 into dB by dt. Because of changing magnetic field, this will be the electric field induced, and EMF induced magnitude of it is nothing but electric field induced into ds. So if you put this over here, RO is nothing but x by 2 into dB by dt, and as dB by dt is constant, the rate is constant, so it's just integration of ds, and integration of all of the ds is the length L. So this comes out to be L over 2 into x, which is nothing but r square minus L by 2 whole squared, and into dB over dt. That is option number A. Question number 25 says electrons moving with different speed enter a uniform magnetic field. So there is uniform magnetic field B here, and various electrons are entering with various speeds. They'll move along the circular paths. Okay, so they'll move V cross B, so upwards, but this is negative charge, so they all will move like this. They will have various radius of curvatures. R, how do we find R? So this is a case of cyclotron, and for cyclotron you just need to remember one simple thing, that this force applied by magnetic field QEB gives us the centripetal force, that is mv squared by r. V gets cancelled and we get the formula for R, which is mv over QB. So mass of all the electrons are constant, charge is constant, it's in a constant magnetic field, but velocities differ. So R is proportional to velocity, more will be the radius. So it will not be the same radius with the larger radius. So option number B. Question number 26 says time period. Okay, so in the same question you have to decide the time periods T1 and T2. So time period is the time taken for electron to move one circular rotation. Hence time taken is nothing but distance over velocity. Distance is 2 pi r over velocity. Let's put the formula for r that we got there. 2 pi into mv over qb, and there's one more velocity here. Velocity gets cancelled, and time period comes out to be 2 pi m over qb. Now time period is dependent on mass, which is same for both of them. Q is also same, B is also same, 2 pi is a constant. So time period doesn't care about the velocity, so it will be same for all the electrons. Option number A. Question number 27 says a particle of charge Q and velocity v passes undeflected through a space with non-zero electric field and magnetic field. undeflecting condition will hold. Let's see this condition. So this charged particle is moving in this direction. Let's say it has electric field in this direction, so there is a force of electric field Q into E in this direction. Charge is Q. Now equal and opposite amount of magnetic force will occur in this direction to make it go undeflected. So this FB acting in this direction will be equal to QVB. So for this we need magnetic field to be into the paper. So we can equate these forces. QVB equals Q into E. So QQ gets cancelled. V into B must be equal to E, and also V cross B must have opposite direction of E vector so that they will be in opposite direction. So these are the only two conditions. First says if you reverse the sign of Q and E, Q doesn't even matter. So if you reverse the sign of E, then this will not hold true. Sign of Q and B reverse, same. If you reverse the sign of B, it will not hold true. Changing magnitude, this will not hold true. But if you double the magnitude of both of them, this will just get doubled, this will just get doubled, and 2 will get cancelled. Here also direction is holding true. So D is the correct option. Question number 28 says two particles each of mass m and charge q are made something like this: mass m, charge q, mass m, charge q, and it's rotated about its center like this. You have to find the ratio of magnetic moment of the system and its angular moment of the system. So angular momentum of the system about this point O is pretty simple to calculate. It's equal to mv cross r for first guy plus mv cross r for the second guy, and v cross r comes out to be in the same direction. For this guy also v cross r is upward direction, and for this thing also v cross r comes out to be in upward direction. So this is 2 mv r. Now how do you calculate magnetic moment of a rotating charge? It's pretty easy to calculate. Magnetic moment is equals to n into I into A. But let's take a case where n equals to 1, that is it's rotating by just one rotation. So n is 1. Current produced is equals to charge flown upon T. So charge flown is 2q, and time taken is nothing but 2 pi r over velocity. So we'll put over there 2 pi r, velocity goes to the top, and area lastly is pi r square. So mu comes out to be 1 into 2 qv over 2 pi r into pi r square. Pi gets cancelled, 2 gets cancelled, and r gets cancelled, and mu comes out to be qvr. So what's the ratio of mu over L? qvr over 2mvr. VR gets cancelled, and answer is q over 2m. That is option number A. Question number 29 says a charged particle is released from rest in a region study of uniform electric and magnetic field which are parallel to each other. The particle moves in. So here is our charged particle. Electric field and magnetic field are parallel to each other, so it will accelerate in this direction with QE. So it will gain some velocity equals u plus at. At will be force QE over m into t. Now this velocity, as it is parallel to B vector, there is no magnetic force, so it will continue to move in a straight line. So option number A. So the final question, question number 30, it says an ionized gas contains both positive and negative ions. If it is subjected simultaneously to electric field along plus x and magnetic field along plus z, so here we have a container, plus minus, electric field is along plus x direction and magnetic field is along plus z direction. Now what will happen? So because of electric field in plus x direction, all the positive charges will start to move in plus x direction, but negative charges will start to move in negative direction, and because of their motion, magnetic field will also work on them. That will be equal to V cross B, and V cross B comes out to be downward for positive, and V cross B comes out to be upward for negative, but it will be in opposite direction because it's a negative charge. So both of these charges are deflecting towards this downward direction. Hence option number C.